Assalamu alaikum. Good morning, everyone. My name is MD SAHIN and today I will present my research proposal titled Developing and Evaluating an Explainable Business Intelligence Framework for Predictive Analytics and Data-Driven Decision Making, a case study in sales analytics. Thank you for this opportunity. Presentation roadmap. Before I begin, let me briefly outline today's presentation. First, I will introduce the background and research motivation. Then, I will discuss the research problem and identifying the existing research gap. Then, I will present the proposed explainable business intelligence framework, followed by the research methodology and implementation plan. Finally, I will explain the evaluation approach, expected contribution, limitation, future work, and conclude the presentation. Next, background and motivation. Imagine a sales manager is told that product sales will decrease next month. A prediction alone is not enough. The manager also need to know why. Is it because of price changes, promotion, seasonal demand, or regional trends? Explainable business intelligence answered this question by transforming prediction into understandable business insights and support better decision. Next, problem statement. Traditional business intelligence mainly explain past performance rather than future outcomes. Many predictive models work as black boxes, making it difficult for managers to understand or trust their prediction. Although previous studies examine business intelligence, predictive analytics, explainable AI, and user evaluation, they often treat these areas separately. Therefore, this is still a need for an integrated explainable business intelligence framework for sales decision making. Next, research question. To address this research problem, the study is guided by six research questions. The first two questions focus on identifying the requirement and designing the explainable business intelligence framework. The next two examine the selection of suitable predictive um, models and how explainable AI technique can provide meaningful explanation for future sales prediction. Finally, the last two evaluate whether the proposed framework improves user understanding, support better decision making, and leads to practical design recommendation for future explainable business intelligence system. Next, business objective. This research has six objectives: identifying the framework requirement, designing the explainable business intelligence framework, development, develop a sales analytics prototype, integrate explainability technique, evaluate forecasting performance, access user understanding, and decision support. Literature foundation and gap. This literature provides valuable contribution in several areas. Some studies focus on business intelligence, other concentrate on sales forecasting. Some investigate explainable AI technique such as SHAP and LIME. Other evaluate user trust and usability. However, few studies combine all these components into one integrated explainable business intelligence framework for sales analytics. This research aim to bridge gap. Proposed conceptual framework. This proposed framework consists of five layers: sales data management, predictive analytics, explainability, business intelligence, visualization, decision support, and evaluation. Together, this layer produce a system that is accurate, explainable, usable, and valuable for business decision making. Next, methodology. This study follow the design science research methodology because it develop and evaluate a practical artifact. This process include identifying the problem, gathering requirement, designing the framework, developing a prototype, evaluating its performance, and refining the final solution. The prototype will use historical sales data, Python-based machine learning, and an interactive Streamlight or Power BI dashboard. Next, data modeling and explainability. The implementation follows five steps. First, collect historical sales data. Second, clean the data and prepare feature. Third, train models such as linear regression, random forest, and XGBoost, and others. Fourth, compare model performance using mean absolute error, root mean squared error, root absolute error, and R squared. Finally, use SHAP to explain both overall model behavior and individual prediction. It is important to remember that explainability helps us understand model decision but does not prove causation. Next, evaluation plan. The framework will be evaluated in two ways. First, technical evaluation will measure forecasting accuracy. Second, user-centered evaluation will examine usability, trust, understanding, and decision quality by comparing a traditional business intelligence dashboard with the explainable business intelligence dashboard. This ensures that both model performance and practical usefulness are assured. Next, expected contribution. This research is expected to develop a novel explainable business intelligence framework, build a functional sales analytics prototype, evaluate both technical performance and user experience, provide practical design guidelines for future explainable business intelligence system. Limitation. This study focus on sales case study, selected dataset and models, a limited user sample, and a prototype rather than a full enterprise system. Feature work. Feature work can validate the fr- framework using real corporate data, larger user studies, real-time business intelligence integration, advanced machine learning models, and reasonable AI practices. Next, conclusion. In conclusion, accurate prediction is alone are not enough. Managers also need to understand why predictions are made before making important business decisions. This research proposed an explainable business intelligence framework that combines predictive analysis, explainable AI, and business intelligence dashboard to support transparent and reliable self decision making. Thank you for your attention. Next, the references I used for this research.